Hey, it's great to have you back. You've learned so much already, and now you're ready to start analyzing data. Coming up, we'll cover some final things you'll need to do for your analysis to make sure your data is formatted and adjusted correctly. We'll start converting and formatting your data using data validation in spreadsheets and conditional formatting. You'll also learn how to combine multiple pieces of data. And finally, we'll talk about how to get support during your analysis and find resources whenever you're stuck. These skills will help make sure that your data analysis process is as smooth as possible, even when it isn't. You'll know how to tackle any problems that might come up. A big piece of being an analyst is troubleshooting and problem solving. You're as good of an analyst as your ability to ask the right questions, which is why we'll spend some time learning about problem-solving strategies you can use during analysis. So whenever you're ready to start learning about data formatting and solving problems, head to the next video and we'll get started. Hey there! So far, we've learned about typecasting data with SQL as a way of converting data from one type to another in databases. Now, I want to check out another way to format data types within spreadsheets. In this video, we'll talk more about why making sure your data is formatted properly is so important, and how to format numbers and convert units of measurement in your spreadsheets. Let's get started. Sometimes you need to convert data when you're working with spreadsheets. That might mean changing numbers into dates, strings, percentages, or even currency. It's important to double-check that all of your data is in the right format for your analysis. Sometimes, even after cleaning and processing data, it still might not be in the right format you need. Let's think back to the table with movie data from before. There were a lot of different data types that included numbers, such as dates, budgets, and text strings, like actors' names. These are distinct values, but the spreadsheet doesn't always automatically know that. Here's an example. Let's say you wanted to sort the movies in this spreadsheet by most recent. If the spreadsheet casts them as strings instead of dates, it might sort them alphabetically. Until you change the data type, you won't be able to sort them the way you want. It's also possible that your data sets contain inconsistent units of measurement that you'll need to convert, like say a table that includes both US dollars and English pounds. That's why it's important to check those data types again, so you don't run into any problems during the actual analysis. Think about the incorrectly cast dates in our movie table. If your boss needed a list of the 20 most recent movies, but your spreadsheet was organized alphabetically instead of by the most recent, you wouldn't be giving her the list of movies she needed. Incorrectly formatted data can lead to time-consuming mistakes in your analysis and might end up affecting your stakeholders' decision-making. But taking the time early on to convert and format your data can help you avoid that. And now that you know why you'll need to convert data types while working in spreadsheets, let's find out how. First, let me show you a really useful menu for specifying data types in spreadsheets. Here's the movie data table we used before, but now the money columns aren't typed as currency. On the toolbar at the top of the sheet, you'll find a menu that can help you convert these numbers into specific data types. It gives you a lot of choices just from the drop-down menu, such as number, currency, date, percentage. And if you click to open the full menu, there's even more options, including one for a custom number format. We know that we want these columns to be in currency format, so let's do that. All I have to do is select this column and then hit the currency shortcut. And now it's all typed correctly. But it doesn't stop there. You can go even further and convert the unit of measurement you're using. For this example, let's check out a different table. Imagine that you're working with a weather channel to gather data about daily temperatures. You have a table with some data about daily observations on the temperature, wind speed, and precipitation in this area. Right now, the temperatures are in Fahrenheit, but for your analysis, you need them to be in Celsius. No problem. All you need to do is use the convert function to change the unit of measurement. We'll use this empty column here. Here's the first temperature in the table. We'll input the convert function in our new column to change it to Celsius. Then we need to put what cell we want converted. And finally, we're going to convert. And presto, now this cell has the right unit of measurement for your analysis. You can simply apply it to the rest of this column. Now, this temperature data is all in Celsius and your unit of measurement is consistent across the table. And here's another tip. When adding data to tables using a formula, go back and paste the data in as values afterwards. That way, they're locked in. Otherwise, the cell stays as a formula and could get confusing when you start working with the data. So let's do that now. We'll copy the values and then right-click in a new column. There's an option for Paste Special, and there's an option to paste values only. And now we have the static values in this column. Making sure your data is in the right format before you start analysis is so important. Do this, and your analysis will return the kinds of answers you're really searching for. And now you know some ways to typecast numbers and convert units of measurement in spreadsheets. You can feel confident your data is formatted the right way. Next up, we'll talk more about adjusting your data for analysis and data validation. See you soon. Welcome back. While we're learning about formatting data, I want to talk to you about another spreadsheet feature, data validation. In this video, I'll teach you a little bit about data validation and show you how to use it. For now, when I say data validation, I'm talking about the function, which is different from the data validation process. We'll get into that later on. But first, let's talk about what data validation does in spreadsheets. Basically, it allows you to control what can and can't be entered in your worksheet. Usually, data validation is used to add drop-down lists to cells with predetermined options for users to choose from. If you have a spreadsheet with a lot of collaborators, this can make it easier for them to interact with your table. You can think of it like a multiple choice question on a quiz. And since you can control what's being entered into the worksheet, it cuts down on how much data cleaning you have to do later on. Let's figure out how we might do that. For this example, we'll work on a project with a lot of milestones and deadlines to keep track of. Let's say our team has a spreadsheet that tracks everyone's progress. But instead of making everyone write in where they are on their task individually, we can provide a drop-down menu with multiple options like Not Yet Started, In Progress, and Ready. So we'll select the column that we want to add the drop-down menus to, in this case, the status column. Then we'll go to the Data pull-down menu here at the top and click Data Validation. This brings up a pop-up menu with options for data validation. In this case, we know that we want to add a list of items for other users to choose from. So we'll select the List of Items option and the possible criteria and type in the selections we want to create. Then hit Save, and now all of those cells have drop-down menus that we can use to easily mark progress for each task. But there's other things that you can do with data validation in spreadsheets too, like creating custom checkboxes. To do this, let's select the cells under the Review column to make a checkbox that will let us know if tasks have been approved or not. We'll go back to the data validation menu. But instead of choosing List from a range, we'll choose Checkbox. There's an option to use custom cell values. Let's choose that and put in Approved and Not Approved. Now these tasks can be checked off by whoever's reviewing them, like a project manager, for example. Another way we can use data validation is to protect structured data and formulas. The more people that are working together in a spreadsheet, the more likely someone can accidentally break a formula. But good news, the data validation menu has an option to reject invalid inputs, which helps make sure our custom tools will continue to run correctly, even if someone puts the wrong data in by mistake. All right, now you know 3 uses for data validation in your spreadsheets: adding drop-down lists, creating custom checkboxes, and protecting structured data and formulas. Data validation can help your team track progress, protect your tables from breaking when working in big teams, and help you customize tables to your needs. Coming up, we'll learn more about conditional formatting and some ways you can use conditional formatting and data validation together. See you soon! Hi again. So earlier we talked about conditional formatting as a spreadsheet tool that changes how cells appear when values meet specific conditions. This lets you add visual cues to your spreadsheets that make it easier to understand your table at a glance, and it makes the information in the worksheet clearer to your stakeholders. In this video, we'll take that even further by combining conditional formatting and data validation to create custom tools for our spreadsheets. So far, we've used conditional formatting to highlight empty cells that still needed data so that we could quickly pinpoint what information our table was missing and add it in. Now, let's build on that by using it to make our scheduling table easier to read at a glance. Here's a table we worked with when we covered data validation. It's tracking the status of different tasks on our project for our team to check on. But now there's even more tasks than the last time we looked at it. This table has useful information, but it takes a second to understand. Right now, we don't have a visual on how many tasks are in progress or how many upcoming deadlines there are. But if we color-coded those elements of the table, we could quickly see key pieces of data really easily. Let's start with the status column, column C. In the last example, we created these drop-down menus with the data validation tool. Now we can use conditional formatting to add some color. Let's go to the conditional formatting option under the Format menu. This brings up a sidebar where we can select our range, rule, and formatting style. We need to decide which rows to apply our formatting to when the condition we set is met. We can click this button in the range options to select all of the rows we're applying the formatting to instead of typing it in. Now that we have those cells selected, we can choose the rule that we want to apply to these cells. We already have drop-down menus with specific text, so we can choose Format Cells if text is exactly from the rules. For our first rule, let's write Not Yet Started as the text condition. Then we'll choose a color to apply to those cells that have not yet started in them. Let's use red. Now all cells that have not yet started selected from the drop-down menu will be red. Let's hit the Add Another Rule button to add conditional formatting to our other status options. Let's add the condition In Progress next. We can make that one yellow. And then we'll add one last rule for ready. Let's choose green. And there. Now we have an easy to understand visual cue that tells us how many tasks are in progress and how many are completed. We can also combine data validation and conditional formatting to track upcoming deadlines. We have a column of dates called Review by this date. First, let's use the data validation functionality to make sure users only enter valid dates. We'll go back to the data dropdown at the top, pull up data validation, and select date as our criteria. Then we can go to the Format menu at the top. Go down to Conditional Formatting and open the sidebar again. We'll click the Select Range icon and select the Review by this date column. Now under Format Rules, we can select Date as After, which will give us another option. Let's choose Today. And finally, let's choose the color for these cells. So if the date listed in these rows is after today, it'll be filled in orange. You can also choose a specific locked date if needed. But for now, let's go with today. Now all of the upcoming review dates have an easy to see color code, so anyone using this table can quickly reference these deadlines. You'll find that some spreadsheet programs like Excel have built-in color codes that you can use too. And there you go. Now you know how to use data validation and conditional formatting to create custom tools and visual cues that make your information easy to understand. There's a lot of different ways to use these tools, so feel free to experiment with them in your own spreadsheets. Coming up, we'll keep learning about new tools for spreadsheets and SQL. Bye for now. Great to see you back. In this video, we'll build on what we learned about concatenate and import range by exploring a new SQL query, concat. You might remember that concatenate is a function that joins together two or more text strings. And as a quick reminder, a text string is a group of characters within a cell, most often composed of letters. You've seen how this works within a single spreadsheet. But there's a similar function in SQL that allows you to join multiple text strings from multiple sources, concat. Let's use concat to combine strings from multiple tables to create new strings. For this example, we'll use open data from Citi Bike, which is a public bike sharing system in New York. As you learned earlier, open data initiatives have created a ton of data for analysts to use. Openness, or open data, is free access, usage, and sharing of data. It's a great resource if you want to practice or experiment with the data analysis tools you've been learning here. We have open access to the New York City bike sharing data, which has information about the use of the shared bikes across the city. So now we can use concat to pull and concatenate data from the different columns stored here. The first thing we need to do is figure out which columns we need. That way, we can tell SQL where the strings we want are. For example, the bike sharing company has two different kinds of customers, one-time paying customers and subscribers. Let's say we want to find out what routes are most popular with different user types. To do that, we need to create strings of recognizable route names that we can count and sort. We know that the information we need is in the station and trips table. So we'll start building our query accordingly. First, we'll input select user type to let SQL know that we want it as a column. Then we'll use concat to combine the names of the beginning and ending stations for each trip in a new column. We'll type in as route to make a route column. This will make these route names easy for us to read and understand. After that, we'll want SQL to count the number of trips, so we'll input count and an asterisk to tell it to count up the number of rows in the data we're selecting, where each row represents a trip in a new column. Now, let's also create a column for trip duration, which we can just round up. Notice how our SQL functions first cast the values in the trip duration column as integers, then calculates the average value for the trip duration, and then rounds that value to 2 decimal places. Next, we'll tell SQL where this information is stored, so we'll use from and the location we're pulling from. Since we're using count and average functions in our select clause, we have to use group by to group together summary rows. Let's group by the start station, the end station, and the user type for this query. Finally, we'll use order by to tell it how we want to organize the data. For this, we want to figure out the most common trips, so we can input the number of trips column and use des to put it in descending order. Finally, we only want the top 10, so let's add limit 10. And now, thanks to concat, we can easily read the route names and trace them back to real places. We can see which kinds of customers are taking which routes, which can help the bike sharing company understand their user base in different parts of the city and where to keep more bikes for people to rent. Being able to combine multiple pieces of data can give you new ways to organize and analyze data, and there's a lot of different tools to help you do that. Now you've seen concat in action, and later you'll come across another similar query, join. But up next, we'll talk more about working with strings. See you soon. Hey, welcome back. So far, we've worked with strings in both SQL and spreadsheets before, and we've learned that they usually have similar functions. In this video, we'll take another look at len, left, right, and find. You've come across these functions used in SQL, but now you'll find out how they work in spreadsheets. Going back to our bike sharing dataset, let's check out one of their spreadsheets. This is one of the trip data spreadsheets. In the start time and stop time columns, there are strings that contain information about date and time of each ride. This is all useful data, but chances are we'll only need part of these strings to make a formula or answer a question. For example, these strings contain multiple data points, like date and time. But if we're trying to find the average time between start times, we won't need the date. We can actually use len, left, and right, and find to split the timestamps into separate columns if we want. Let's build a simple formula to separate the dates in these strings. We know that len tells us the length of a string. Let's check how long these date time strings are now. To start, we'll input the first part of the formula. And then we'll just select one of the cells with the date time string in it. These strings are 19 characters long. We can use the find function to locate specific characters in a string. Keep in mind, this is case sensitive, so if you're using find to pull a substring, make sure that you've input the substring correctly. We notice that all of the datetime strings have a space separating the date and the timestamp, so we can actually use find to figure out where the date ends. Okay, seems like the space is the 11th character in this string, so the timestamp substring will start at character 12. We can use the left and right functions to select which parts of the string we want to isolate in a new column. We'll use right on one of these cells to indicate that we want to grab the right side. And like we've come across before, left actually works exactly the same way. Now we can apply that to the rest of column C to pull those timestamps. As a data analyst, being able to work with strings is a key skill, especially when you find yourself working with data from outside sources. Hopefully you're a little bit more comfortable applying len, right, left, and find functions in both SQL and spreadsheets. Later on, we'll use these functions to perform even more complicated formulas, so feel free to try them out on some data yourself. Maybe even some open data like we've been using today. See you later. Hi there. So data analysts spend a lot of time problem solving, and that means there's going to be times when you get stuck. But the trick is knowing what to do when that happens. In this video, we'll talk about the importance of knowing how to get help, whether that means asking someone else for help or searching the internet for answers. Asking other people about a problem you're having can help you find new solutions that move a project forward. So it's always a good idea to reach out to your peers and mentors, especially if they're working with you on that project. Your team members have valuable knowledge and insight that can help you find the solution you need to get unstuck. Sometimes we spend a lot of time spinning our wheels saying, I can do this myself. But we can be way more productive if we engage with other people, find new resources to lean on, and try to get as many voices as we can involved. For example, let's say you're working with the bike trip time data from the previous videos. Maybe you're trying to find the average time between bike rides in a given month. Calculating the difference between bike rides before midnight is easy, but you can run into a problem if the elapsed time crosses into the next day. If someone went on a bike ride at 11 p.m., but the next ride wasn't until 6 a.m., your formula will return a negative number because the end time is less than the start time. You know that you can add 1 minus the start time if two bike rides start and end on different days, but that formula won't work on times that happen in the same day. And it's pretty inefficient to scroll through every bike ride to pinpoint these special cases. You need to find a way to build a conditional formula, but you aren't sure how. So you decide to check in with other analysts working on your team to see if they have any ideas. You could send them a quick email or stop by their desk to find out if they have a minute to talk it over with you. Turns out they had a similar problem on a previous project, and they're able to show you a conditional formula that you could use to speed up your calculations. Great. They suggest using an if formula like this. This basically says that if the end time is larger than the start time, replace the standard end time minus start time formula with 1 minus start time plus end time. Now, it's also possible that your team members don't have an answer. That's okay too. There's definitely someone else with the same problem asking the same questions online. Knowing how to find solutions online is an incredibly valuable problem-solving tool for data analysis. There's also all kinds of forums where spreadsheet users can ask questions. and you never know what you can turn up with just a basic search. For example, let's say you look at calculate number of hours between times spreadsheets and find a helpful walkthrough for a more complicated formula using mod. This flips the negative values into positive ones, solving your calculation problem. Whether you're asking someone you know or searching the internet for answers, reaching out for help can give you some really interesting solutions and new ways to solve problems for future analysis. Coming up, we'll learn even more about searching for solutions online. See you soon!
Hi, my name is Layla, and I'm an analytical lead at Google. So an analytical lead is someone who helps advertisers understand the value of their advertising dollars. We also help them understand if they were to spend another dollar on ads, where should they spend that dollar, and what could they expect to get from it. The skill set involved in this kind of role has all to do with being able to look at a data set and make sense of it, and then tell a story to people who maybe don't have that same experience level with data. What's going on in the data? What's driving growth for your client or your company? What could they do more of or less of to drive more of what they want to happen? The analyze stage is like preparing a fabulous meal. You have done all the cleaning and the preparing and the cooking, and you're finally able to take a bite and to see if what you were originally hoping to happen or what you were expecting, to see if that is really the case. Is it delicious? Is it exactly like you expected? Or is the consistency a little off and you need to add a little bit more salt? The analysis stage begins once you've prepped and cleaned your data. You don't want to have those blank fields that will throw you off or duplicate entries that will enlarge your data set beyond what's actually true. The analyze stage is where you become the expert about your data set. Here you're going to understand all of the different fields. You're going to understand their averages, potentially the median of the data. You're going to understand how different rows in your data differ from each other. And it's where you're going to gain the confidence to be able to explain your findings to an audience that maybe does not have the same level of expertise with data that you have. When I analyze data, I often like to use SQL and spreadsheets. You can use these tools to, for example, sort your data and understand which entries are larger than others, or to understand how many times something happens by selecting maybe the distinct entries. Here you can also filter out data that you're specifically interested in analyzing, or in a spreadsheet, use conditional formatting to show which entries show a more positive outcome and which ones are maybe more negative. Using SQL and spreadsheets to help you through the analyze phase are absolutely crucial. With these tools, you can format your data set in a way that is digestible and then begin to tell a story with the data. My favorite part of working in a spreadsheet is when you finally have that data that you want cleaned up and exported from your SQL query. Then you get to turn it into a pivot table and chart out exactly the cut of data that you were interested in looking at in the first place and explore the trends that are happening there. When you get to do that, you basically unlock a whole world of information, and you get to pick what story that you actually want to tell with your data without just saying, okay, this is the largest number, that's the smallest number. Here you get to show what is happening over time potentially, or what you should expect to see in the future.
Welcome back. Earlier, we talked a little bit about finding resources online to help you figure out solutions to problems during analysis. The internet has so much knowledge and advice to offer, but you need to know how to find it. So in this video, we'll talk more about finding answers online. You might think that great data analysts don't regularly rely on outside resources, but that's a myth. The best data analysts know that finding answers to their problems online can be empowering and give them new knowledge for the future. Being able to find new ideas and combine them with what you already know can help you come up with some amazing things. So don't be afraid to turn to the internet to find your answers. It's a great resource that lots of analysts use, me included. But let's talk more about how you can make sure you're using web resources in the best way possible. There's a combination of best practices that you can use to guide your search for answers online. By practicing the thinking skills we've learned in this program, using the right data analytics terms, and your basic knowledge of analysis tools, you have everything you need to find answers and apply them to your own work. And it starts with how you approach a problem mentally. You've learned about different kinds of thinking skills and how to practice them in your data analysis work, from analytical to mathematical to structured thinking. This helps build your mental model or your thought process and the way you approach a problem. Data analysts use these thinking skills to approach a problem logically and break it into smaller parts. Building this into your own problem-solving process can help you pinpoint specific questions which you can use to find resources more easily. For example, maybe you keep running into an error in your analysis. You narrow it down to two possibilities: your formula or the data itself. You double-check your formula and you see that it's correct. So now you know that you need to make sure that data has been entered correctly. You considered the problem logically and tracked it down to the source using your mental model. Next, it's important to use the right terms when searching for solutions. Knowing how to frame data analytics questions with the same language other analysts are using will help you get more search results, and it'll help you understand what other analysts are saying. For example, maybe you need to use the left 4 characters of a string for a column in SQL. How would you search for this? Searching for 4 characters in a column is a little vague and might not bring up specific resources, but left string query SQL uses some keywords that other data analysts are also using to talk about these things. On top of being able to use the right terms to search online, you also need to be familiar with basic tools. That way, when an online resource is walking you through a new function in a tool you've used before, you'll know how those tools work. For example, if you find a spreadsheet formula online, you need to understand how formulas work to apply it to your own spreadsheet. Or maybe the data set you're working with is too large for a single spreadsheet, and you'll need to switch to SQL. Having a variety of tools in your toolkit is important as a data analyst, but just as important is knowing when to use them. If you find yourself stuck on a problem, it can be a good idea to take a step back and reconsider how you're approaching a task. We've covered a lot of tools that you can use as a data analyst throughout this program. And later, you'll learn one more: R. We'll talk about R more later on, but here's a sneak peek to get you excited for it. R is another programming language, but it's not a database language like SQL. It's a programming language frequently used for statistical analysis, visualization, and other data analysis. R is a little different from other tools we've been working with, but it's a great complement for the tools you're already using, and it will give you more potential solutions when you run into problems. Using the thinking skills we've learned throughout this program, the right terms, and your understanding of different analysis tools will get you ready for the next steps of this process: actually searching for answers online. There's a lot of resources like program support websites and forums where other data analysts are asking and answering questions. In an earlier video, we ran into a problem trying to calculate the time elapsed between bike rides and the bike sharing data. Maybe our first search, calculate time in spreadsheets, didn't turn up the answers we needed. By thinking about our specific question and how other data analysts might be asking it, we could change that search into conditional formula for calculating elapsed time in spreadsheets. And now we have more specific solutions to our problem. Finally, being able to modify example code to fit your own needs is so useful. Understanding the syntax of formulas and functions for different tools will allow you to take what you learned online and make it work for you, and maybe even build on it to create a whole new solution. For example, the mod formula we built to account for trips that started and ended on different days in our bike sharing data. The mod formula we found online wasn't created for the data we were working with, but because we are familiar with spreadsheet tools, we were able to apply it to our data and use it as a solution to our problem. Great data analysts know how to find and use resources online to help them build new solutions to problems they face. By using the thinking skills you've already learned in this program and using your knowledge of data analytics tools and terms, you can too. And once you've found some answers to your problems, you can build them into your analysis work to get past any challenge you might face. Hello there! In these videos, you've been introduced to spreadsheets, SQL, and so many other tools. We've also talked about choosing the right tool before you start a project. But sometimes you find yourself stuck on a problem during your data analysis. That might mean it's time to reconsider which tool you're using for the job. For example, if you're working with a simple spreadsheet, maybe 5 to 10 rows and a few columns, then pivot tables are a great way to visualize that data. But if that spreadsheet is more than 1 million rows, it'll start to crash, making a pivot table hard to complete. When you find yourself working with a huge spreadsheet that keeps crashing, you might switch to SQL to pull the data you need from different locations in a database instead of from a single spreadsheet. You might remember that SQL can handle trillions of rows of data and is now a standard language for working with database programs. SQL is great for querying, updating, and optimizing data. But trying to analyze your data with only SQL can get complicated. As you continue to progress as a data analyst, you might find yourself spending a lot of time building long, nested queries and then debugging them. It might be time to consider another tool, R. R is a new tool that you'll work with later on, but for now, I'll tell you a little bit about it so that you can start getting excited. R is another programming language, but it's not a database language like SQL. It's a programming language frequently used for statistical analysis, visualization, and other data analysis. R is a little different from other tools we've been working with, but it's a great complement for the tools you're already using. With R, you'll be able to analyze and visualize data in all kinds of new ways. We'll talk about R more later on, but I hope this sneak peek gives you an exciting first look. Having a variety of tools in your toolkit is important as a data analyst, but just as important is knowing when to use them. If you find yourself stuck on a problem, it can be a good idea to take a step back and reconsider how you're approaching a task. Do you have too much data for a single spreadsheet? Switch to SQL. Are you spending more time debugging queries than actually analyzing data? Maybe you should consider R. You also know how to find answers online now, so if you ever run into a problem and need to try a different tool, a quick search can be really helpful. There might be resources online, or someone else may have had the same problem and posted about it. This is great if you start feeling stuck on a problem, and you might even find a new way to use a tool you're already familiar with. And that brings us to the end of this module. Great job! We've covered a lot of information. We learned about converting and formatting data, how to combine multiple pieces of data, and how to search for help when you need support during your analysis. Coming up next, you'll take on the weekly challenge. As always, feel free to go back over anything we've learned from these past videos. Then I'll see you for the next video. Good luck!
Thank you for watching our video. We hope you found it helpful. If you enjoyed this video, please hit the like button below and subscribe to our channel for more videos like this. If you know someone who could benefit from this information, please share it with them. We would love to hear your thoughts on this learning course, so please leave a comment below. Thanks again for watching, and we'll see you in the next video.